Hello and welcome back to my short keypad series, how to integrate a keypad into your electronic circuits. In the last video, we introduced the 7447 BCD to 7-segment display driver so that when we pressed a number on our keypad, it would show up on a 7-segment display. Well, the problem with the 7447 is it only counts from 0 to 9, and again, only sequentially. So it doesn't matter what numbers you have on your keypad, it's going to show 0 through 9. And of course, we want to display all the hexadecimal digits from 0 to F. So now we're going to have to move to something a little bit, has a little bit more power to it. So we're going to move to a ROM chip here, the 28C16 2K by 8 EEPROM. Now, we're going to have to burn the chip, which means, we're going to have to put some codes into the chip to represent the 7-segment displays that we want to show up, 0 through F. This is the actual codes for those. And you find these codes by using this table down here. It looks a lot worse than it actually is. Here's your 7-segment display, and you got to realize there's two flavors of 7-segment displays. You have common anode, which means you have the common pin is the plus voltage, and then you use a logic 0 on pins to light them up. So if you want a 0 here, you want to light up A, B, C, D, E, and F. So you would put a logic 0 on A, B, C, D, E, and F, and put a logic 1 on G, and that would make this one turn off. So let's take a look at the logic table here. Again, for a 0 here, we want to turn everything off except for the G. So here we have A, B, C, D, E, F, and G is turned on. Now for a 1, the only ones we want to have on is B and C. So these two would be a logic 0, B and C. And you see that here. B and C are logic 0s, and everything else is a logic 1 to turn them off. Now the common cathode is just about the opposite, is exactly the opposite. You have the negative voltage on your common pin here, and you require a logic high on A, B, C, D, E, and F to create a 0, and a low to turn something off. So for a 0, you have everything turned on except for the G. And for a 1, the only ones you want turned on is B and C. So again, we have B and C turned on. Everything else is a 0. Now there's 4 ways of looking at these tables. You got forward with the DP, reverse with the DP, without the DP forward, and without the DP reverse. Let me show you how that's done. Here's the forward with DP. So here's your DP, and we're going to just read this naturally from left to right. You got a 1, 0, 0, 0, which is an 8, and a 0, 0, 0, 1. So you have 81 here. For the number 1, you have a 1, 1, 0, 0, which is a C, and then a 1, 1, 1, 1, 1, which is a CF. And so on. You can read those down as you go. Now reverse is obviously the other way. You look from this side and you read from right to left. So you got a 1, 0, 0, 0, which again is an 8, and a 0, 0, 0, 1, which is 81. That's just a coincidence. And when you look at the numeral 1, reading it reverse, you have a 1, 1, 1, 1, which is F, and a 0, 0, 1, 1. So that's an F3. Now, without the DP, basically you just don't count this road, and if you're reading forward, you start on this side, but you only count these first 3 bits. So you got 0, 0, 0, and then the low byte is 0, 0, 0, 1. So it's a 0, 1. Then for a 1, you have 1, 0, 0, which is a 4, and a 1, 1, 1, 1, which is a 4F. And reverse, again, you go the opposite way, and this is the one I'm actually using. So for 0, you have a 1, 0, 0, and then a 0, 0, 0, 0. So you got 4, 0. And then for the 1, you have a 1, 1, 1 here. and then a 1001, which is a 79. Okay? I don't want to spend too much time on this table. You can just take a look at it. You can write it all down, print it all out, take a screen capture. I've done both of them for you, common cathode, common anode, forward, reverse, with DP, without DP. So just take a quick screenshot of that. And now we can go over the pin assignments here. As you can see, from pin 8, from 1 to pin 8, you have address lines. From pin 8, you have 0, A0, A1, A2, and A3, which are the only ones we're really concerned on because we only have 4 inputs coming from our 74C992 keypad decoder. So the rest of these, we're going to just tie these all to ground. And the same with A8, A9, and A10. And then you have your IOs from 0, 1, 2, and on this side 3, 4, 5, 6, 7. We're going to tie those over to our 7-segment display with 0 going to A, 1 going to B, 2 going to C, and so on and so forth. Except for 7, we're not going to tie that because we're not interested in the display in the digital point there. Of course, you have BCC on pin 24 and ground on pin 12. On pin 21, we have a write enable. Well, we do not want to be able to write to this chip or accidentally write to this chip, so we're going to tie that one high. Then you have control pin output enabled. We want these to be outputs. They could be inputs or outputs. We want them to be outputs, so we're going to tie that low. And then chip enable, of course, we need that low to be able to work with the chip at all. So let's go ahead and wire this thing up and see if we can't get that working. Oh, wait, time out. I got to program a chip. So I'm going to show you how to program a chip. It's not like programming. We're just going to enter these codes from 0 to F, and that'll be it. So let's get started. Over here we have our programmer. And you always want to pay attention to, the key on your chip. I'm going to put that up there at the top. Lock her down. We're going to go back to the screen here, and we'll actually enter these codes. Let's see, there's my program. Let's see, can we see everything here? We've got to see it all. Okay. We're going to just start right here. Or first I'm going to do a read, because you always want to do a read to make sure that this is a brand new chip, so everything is FFFFFFFF. So we're going to go ahead and start programming right from here, and we'll put our 4079243019 1202 78 00 18 08 03 46 21 06 and 0E. That looks good. And then we're just going to hit program up here and program. And that'll write the codes that we just entered in there onto the ROM so that we can use it. Alright, I always like to do a read after I write something to make sure everything's in there correctly, and then go over it again. 40, 79, 24, 30, 19, 12, 02, 78, 00, 18, 08, 03, 46, 21, 06, and 0E. Yep, that all looks good. So now we're ready to wire this thing up and see if it actually works for us. Okay, we'll start with our inputs here. I'm going to take our A input and put that at pin 8. 10, 9, 8. And put our B input at pin 7. C to pin 6. And then D to pin 5. Okay, go in there. And like I said, we're going to tie the rest of these address lines on this side to logic 0 because we don't want to read them. So we can get that. Goodness. Things don't always behave. Okay, now let's flip this over. Like I said, pin 23 and 22 are both address lines. So we're going to tie those low as well. Now we get to pin 21, which is the write enable, which we're going to tie that high because we do not want to be able to write through this chip. Come on, baby, get in there. And the next one, right next to the write enable, pin 20, is the output enable, and we want to tie that low so that it will be outputting to our 7-segment display. Yep, I'm getting the right hole. Oh no, you fell out. Let's put you back in. There. Come on. Start behaving. There you go. And stay there. Now our output enable, we're going to go low with that. And then our final address line, which is A10 on pin 19, we're going to hold that low. And then our last control line is chip enable on pin 18. We're going to hold that low as well. Alright, the only thing left to do is to plug in our 7-segment display. So let's start over here at pin 9 and take that over to A of our 7-segment display. And pin 10, go to B. And 11. 11 will go to C. And pin 13. Go to D. And 14. Go here to E. 15. Go to F. And we'll go to G. All right, we're all plugged in there. Let's see if this thing works. Okay. Well, I'm seeing a B over there. Let's see if we hit 1. We got a 0. Well, we need a little push on one of these. Okay. Here's our problem. Try that again. At a 0, a 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F. Okay, that's working. Looks nice. Now, again, we have the old problem. We don't want this to be a 0. We don't want our 1 to be a 0, and we don't want our A to be a 3. So let's see if we can't fix that by reprogramming our ROM chip to display the right characters in the same order as our keypad has them. Okay, this is the codes as we put them in, which goes from 0 to F sequentially. Now what we want to do is we want to move these around more like we have them over here on this side, where you have 1, 2, 3, and then an A, then 4, 5, 6, and then the B, 7, 8, 9, and C. Then we have E and F on both sides of the 0, and then finally D. So let's go ahead and program that in our ROM. Oops, wrong thing there. Okay, let's go ahead and read what we have in there. I'll make sure you can see everything. Let's read what we have in this ROM right now. And that has our regular configuration with 40, 79, 40 being a 0, and we want to start with 1. So we want to start with 79 over here. So let's go ahead and program this. 79, 24, 30, 08, 19, 12, 02, 03, 78, 00, 18, 46, 06, 40, 0E, and 21. Okay, that looks good. Let's go ahead and program it. Go back and go read. Come back, and everything looks like it's in place. So let's go ahead and swap that chip and see if our keypad doesn't show up correctly now. Okay, we got the new chip back in there, and let's plug in power and see what we have. Okay, we have a 1. And now we have a 1 instead of a 0. We have a 2, a 3, an A over here, 4, 5, 6, and a B, 7, 8, 9, and a C. And we have a D down here. We have an E over here, a 0 in the middle, and an F. So now we have the keypad all programmed correctly. That's great. Using the 7216 EEPROM. That's great. All right. I hope everybody was able to follow along and get everything that I was showing you here. And we'll be back. The next challenge will be a bigger keypad I'm going to look at installing another keypad that has a few extra buttons on it, and we won't probably be able to use the 74C922 decoder, and we're going to have to actually use a microprocessor, which means we will actually have to write some code, actual programming, to get it to work, because we're going to have to poll all the rows and the columns to find out which button gets pressed. But that's for another video. Thank you for watching. Have a great day.